So explain the following terms with suitable examples. First part is Schottky defect. Answer is the Schottky defect is basically a vacancy defect in ionic solids. To maintain electrical neutrality, the number of missing cations and anions are equal as shown in the figure. Schottky defect decreases the density of the substance. The number of such defects in ionic solids is quite significant. So, what does the Schottky defect means? It means that in an ionic solid, there are many cations and anions present. So, suppose X amount of cations leave the ionic solid and move away. So, if X amount of cations moves, then there is a vacancy of X anions also in that particular ionic solids, so that the electrical neutrality is maintained because the number of cations as well as number of anions that are missing are equal. Okay, so since there is a movement of cations and anions out of the ionic solids, therefore there is a decrease in the density of the substance. For example, in NaCl, sodium chloride, there are approximately 106 Schottky pairs per centimeter cube at room temperature. In 1 centimeter cube, there are about 1022 ions. Thus, there is one Schottky defect per 1016 ions. The Schottky defect is shown by the ionic substances in which the cation and anions are of almost similar sizes. For example, NaCl, KCl, CSCl, and AgBr. You don't have to learn the data given here, 106 and 1022 and 1016. This is just to increase your knowledge and make things interesting. You can see that plus minus the number of vacancy is evenly distributed amongst the positive as well as the negative. Second is, what do you mean by Frankel defect? So it is shown, Frankel defect is shown by ionic solids. The smaller ion, usually cation, is dislocated from its normal position to an interstitial site as shown in the figure. It creates a vacancy defect at its original site and an interstitial defect at its new site. Frankel defect is also called a dislocation defect. Frankel defect does not affect the density of the solid. Frankel defect is shown by the ionic substance in which there is a large difference in size of cations and anions. For example, ZnS, AgCl, AgBr, and AgI due to small size of cations and large size of anions. Frankel effect can be observed in this. As you can see, in AgBr we can see both the Frankel defect as well as the Schottky defect. So in Frankel defect, in an ionic solid, as you can see in the figure, suppose this plus charge jumps from this location to some other location. So there is a vacancy in this, but the plus charge still remains in this ionic solid. So the density does not change in the Frankel defect. Okay. So third is we have to define the term interstitial. So so in interstitial defect, when some constituent particles, atoms or molecules occupy an interstitial site, as shown in the figure, the crystal is said to have the interstitial defect. This defect increases the density of a substance. Interstitial defects can be shown by non-ionic solids. This is a figure representing the interstitial defect as shown. Now, the fourth part is F centers. You have to define F centers. When any negative ion is absent from lattice site, then the crystal now has an excess of cations. To maintain electrical neutrality, the vacant anionic site is occupied by an electron as shown in the figure. The ionic sites occupied by unpaired electrons are called F centers. The F center is responsible for most interstitial properties of the compound. So in F center, In the ionic solids, the negative ion is absent from its lattice side. So it means that there is more positive charges present in the ionic solid as compared to the negative charges. So to maintain electrical neutrality, a vacant ionic site is occupied by an electron. Okay. So the ionic sites occupied by unpaired electrons are called F centers. This defect is observed in NaCl. So as you can see, there is one vacancy. So electron comes and occupies it. So the compound exhibits electrical neutrality.